Hello friends, in this video we will see what is meant by energy sources and we will see the classification of energy sources also. So let's start with energy sources now. They are classified like this: ideal source versus practical source. And then in ideal source, again we will be learning two types. One is called as voltage source, the other one is called as current source. Similarly, in practical sources also we will see both, that is voltage source and current source. Now the reality is, ideal sources are theoretical sources and practical sources, as the name implied, they are actually practical, they are actually available, that we use them in the circuit. But then while solving the problems, we always assume themselves as they are ideal sources. We will see what are the real differences between ideal sources and practical sources. So we will start with practical voltage source. The practical voltage source is a battery having magnitude, let's say, plus minus Vs. Along with, there will be a series resistance which is connected to it. Let's say the value of this resistor is Rs, across which a load will be connected like RL. Let's say voltage across RL is plus minus VL, and a current which is flowing through RL is, let's say, IL. I can say that in fact the loop current is nothing but IL, because of which I can have voltage drops like this. So I'm going to apply KVL over here and write one equation. So by KVL I can write negative to positive is positive Vs, then positive to negative becomes minus IL times Rs, and then positive to negative will become minus VL equal to 0, or I can say VL equal to Vs minus IL times Rs. So this is my final equation. As you can see that in this equation, I can say that your VL, that is nothing but load voltage, depends on IL, which is nothing but load current. In fact, I can say that VL is actually a function of IL. So exactly what happens when it is function of IL? We'll see. Suppose now I'm trying to plot VL versus IL. This is origin 0. So at this point we can say that IL value equal to 0, and as soon as we are progressing towards this side, IL value is increasing. Am I right? So I'm talking about origin point where IL equal to 0. Let us substitute IL equal to 0 in this equation. Let me say this is equation 1. Let us substitute IL equal to 0 in equation number 1. What you get? Tell me. VL equal to Vs, because IL part equal to 0. So I can say that VL becomes Vs. I can substitute Vs here. Thereafter, as I said, the moment you progress in this line, your IL is increasing. If your IL keeps on increasing, I can say this second term keeps on increasing. You know the fact that your Vs value is constant. So if IL increases, if the second part increases, because of the more subtraction happening, VL will start reducing. So as soon as IL increases, VL starts reducing. So this is what will start happening. At any moment of time, it might happen that VL will reach to 0, which is undesirable. What is expected? That this VL should remain to Vs. It was expected that it remained to Vs. But what you could see practically is there is a drop. There is a drop. And the drop value is how much? It is IL times Rs. So what you can see, there is a practical drop. Of what value? It is IL times Rs value. We say that ideally drop should be equal to 0. If we say ideally drop should be equal to 0, it means we claim that IL times Rs should be equal to 0. Now we can use our common sense. When product becomes 0, product becomes 0 only when one of the value should be 0 or both of them should be 0. What do you think? Do you even think that IL can be 0? No, IL is a load current. Load current should not be 0. What does that mean? Ideally, RS should be equal to 0. Ideally, RS should be equal to 0, and we know the fact that when we say 0 ohms, only when it is short circuit. So please remember, ideally speaking, source resistance is 0 ohms means source resistance will be electrically replaced with short circuit. It means when I'm talking about ideal voltage source, in ideal voltage source, RS value should be equal to 0, but practically RS does exist. Since RS does exist, we have to show them in the figure. Like Vs and Rs are connected in series. Practically Rs value is very less, but ideally Rs value equal to 0. So I can draw ideal voltage source like this. Plus minus Vs, and Rs is replaced with short nav. And this is the point where your RL is connected, across which VL voltage is there. So now if I apply KVL here, you can see that it will be simply VL equal to Vs. Or I can say that VL is no more function of IL. Am I right? IL is a load current which is flowing through RL now. So it is clearly seen that when VL is not a function of IL, there is no problem. But practically VL is a function of IL, as we have seen in the last slide. So this is how your voltage source really works. Practical voltage source and ideal voltage source. Let's move to the practical current source now. Practical current source means a current source, let's say having magnitude as Is and source resistance which is always connected in parallel. This is what we call as practical current source. Let's say to which load resistor is applied RL, through which the another current going called as IL, and current through RS will be IRS like this, and the source current, you can see there is a node formation here. So by KCL I can say that your IS is getting divided into two currents, IRS and IL. So I can write an expression like this: IS equal to IRS plus IL. If IL is the current which is flowing through RL, I can assume the load voltage plus minus VL here. We know the fact that voltage across parallel circuit is same, meaning that if this is plus minus VL, then voltage across this will be also VL. In fact, voltage across current source will be also same value, VL, right? Because voltage in the parallel circuit remains same. In fact, now I can write IS equal to IRS can be replaced by Ohm's law, that is VL by RS plus IL. Or I can say IL is equal to simply IS minus VL upon RS. So now this is the equation of IL, which is nothing but a load current. From this equation, one can clearly say that IL is a function of VL. Practically it does happen that load current is a function of load voltage. So we'll see what exactly happens if it is so. So I'll try to plot IL with respect to VL. So as you can see, let's say this is equation 1. In equation 1, let us substitute VL equal to 0. So VL equal to 0 makes IL equal to IS. So IL equal to IS. Is that right? From this end, now VL starts increasing. As you can see in equation number 1, IS is constant, RS is constant, and VL is variable. As you can see, at this way VL is increasing. So if VL increases, I can say the second term will increase. Second term will increase, the more subtraction will happen, and effectively IL will reduce. So the moment VL starts increasing, IL practically starts decreasing. At any given time, it might happen that IL will become 0. But this is not expected. We expected that IL could remain same. So this is actually a drop value. Is that right? So what you can see, practical drop in load current is equal to how much? It is VL upon RS. We believe that ideally drop value should be equal to 0. So what is the drop value? Drop value is VL by RS. So ideally speaking, VL by RS will be equal to 0. So again we can use our mathematical sense that a ratio can be 0 only if the numerator is 0 or denominator is infinity. As we can see, numerator is VL and VL cannot be 0. It means it is only possible that if RS becomes infinity. So we say that ideally RS should become infinity. And the unit is ohms. RS is tending to infinity, or RS equal to infinity means the source resistance is infinity. So electrically it is open circuit, and therefore ideal current source is drawn the way I am doing this now. We'll have ideal current source with magnitude Is. This RS can be open circuited, and then we have load resistor RL here. This is IL. Drop across this is VL. Now you can clearly see whatever current Is it is sourcing, it is going through RL. So I can see clearly that IL is simply Is, meaning that ideally IL is not a function of VL. But as we have seen, practically IL is a function of VL, because of which now we are facing a drop. I'm sure you have understood these ideal sources and practical sources. Thank you.